Hello all, myself Sambasiva Rao, working as Assistant Professor in the Department of Civil Engineering at VNR VJEC. I welcome you all to the lecture series on highway geometric design, and the topic of discussion for today will be vertical curves. So we have completed our discussion on horizontal curves in terms of circular curve, which is at the central portion, and also the transition curve, which is connecting between the straight portion and the circular curve. Today we are going to discuss the importance of vertical curve. The main reason for providing the horizontal curve is you are going to change the direction. You are going along the straight portion and you have to take a turn either left side or right side. Your designated path is somewhat different, so that is why you are deviating from the original path. So that can be seen in the plan portion. So that is you are encountering in a horizontal curve. Basically the horizontal curve necessity is to change the direction of your travel. But whereas the vertical curve is you are traveling at one level and you want to end up in a different level. So that is why you are going to provide a vertical curve. A vertical curve is going to provide because to reach points of different elevation. So you are at this point somewhere here, okay, and you want to reach at this point. You are going to point, you want to reach at this elevation. So you are providing a rising gradient followed by like this, so which will result in the formation of vertical curve. So that is what main purpose of providing a vertical curve to reach points of different elevation. So this is the horizontal alignment, which is you can see in the plan view, and this vertical alignment like this. This is the point of your RL and you want to reach at a different RL. So you are going to provide like this two tangents, and that will result in the formation of a vertical curve. This is already the same thing. This is the straight portion. This is the point of vertical curvature. This is the point of vertical tangency, and this is the point of vertical point of intersection, vertical curve, and this is horizontal curve. This is again a plan, and this is elevation. Here you are going to have the deviation angle or deflection angle. Here also you are going to have deviation angle or the deflection angle. Only thing is this you can see in elevation, this you can see in the plan. So among the vertical curves you have two different types of curves. One is summit curve and next one is sag curve. Summit curve is like this, which is going to have a concave downwards. So this is cave portion downwards, concave downwards, concave here, and this is convex up, convex upside. This kind of curve is said to be summit curve. This summit curve is also called as crest curve, because this is looking like a crest like this, and this is also called as hilly curve because this is looking like a hill. So this curve is also called as hilly curve. These are the different names for summit curve. One is nothing but crest curve, next one is hilly curve, and summit curve. So the different ways of forming the summit curve is either a rising gradient. Here it is plus is standing for rising gradient. So this is ascending gradient followed a level stretch, that is N2 is 0 or G2 is 0, gradient is 0. Rising gradient meeting a horizontal road, or a rising gradient meeting a falling gradient. So you are having a rising gradient which is meeting a falling gradient. So that will result in the formation of what summit curve. Again there is a rising gradient, a steeper rising gradient meeting a mild rising gradient. So this also will lead in the formation of summit curve. Again a falling gradient meeting another steep falling gradient. So this is minus. Every time falling gradient is represented as minus, and this is also minus, but this is minus is lesser value mild gradient, and this is a steeper value again falling gradient. So falling gradients wherever it is minus and minus. Rising gradient this is plus, and this falling gradient minus, this rising gradient plus, and this is also rising gradient, but this is some different elevation, and this is steeper and this is mild gradient. So this is again upward gradient, rising gradient which is positive, and this is level stretch which is 0. The other way which you can also be formed here, extra one thing. So horizontal road which is meeting a falling gradient. So this is N1 is equal to 0 or G1 is equal to 0, G2 is equal to minus G2. So that case is been missing over here. So this is the different ways how you can attain a summit curve. Anything you want to curve like this formation or like this formation, like this, like this, like this also will form a vertical curve. You can attain vertical curves of this different ways, summit curves particularly. If you look into the sag curve, this is quite opposite of that, concave upwards. So this is cave portion, concave upwards, and this is convex downwards. So this curve exactly, summit curve opposite is sag curve, and hill curve opposite is nothing but valley curve, and crest curve opposite is nothing but trough curve or valley curve. So these are the different names. One is vertical curve like this, previously summit curve, and next one is a valley curve like this. Okay, both of them. So sometimes you might be encountering both of them together at the same time. So a single road can have a curve like this, so then you can form like this. This is one kind of curve and this is one kind of curve. This is sag curve, which is as always smiling curve, and this is a summit curve, which is a crying curve. So sometimes you just remember like this. You can have both of them in combination along the path of your road. So this is different ways how you can form your sag curve. One is a falling gradient of minus meeting a level stage, G2 is equal to 0. Next one, this is a rising gradient meeting another rising gradient. This is higher value, steeper gradient. This is mild, this is steeper, and both of them are rising gradient. So both of them are given positive. And this is falling gradient minus, and this is falling gradient lesser value. Again, both of them are falling gradient, so that is minus. So this is falling gradient minus and this is rising gradient plus. The other way which you can form is a horizontal road meeting up the rising gradient. So this is N1 is equal to 0 or Z1 is equal to 0 and Z2 is equal to plus. So these are different ways how you can form the sag curves. The difference between summit curve and sag curve are crest curve and trough curve, or hill curve and valley curve. This is concave downwards and convex upwards. This is sag curve, concave upwards and concave downwards. Deviation angle is positive, very important. So we have seen the deflection angle in terms of the horizontal curve, and we are looking over here. Deviation angle is positive. Deviation angle is here, it is negative. Deviation angle is negative. This is more comfortable and this is less comfortable. Generally, when you are asked to tell which is more comfortable, actually, yeah, we will feel like valley curve. When we are coming along the valley curve, we use it to tell that it is more comfortable when you are traveling along a sag curve, but that is not the case. You have to look into what are the various forces which are being acted on the curve. For example, this is a summit curve. When you are going along the summit curve, your weight of the vehicle is always acting upwards. Sorry, weight of the vehicle is always acting downwards along with your weight. So this is W. And when you are moving up onto the summit curve, some part of the centrifugal force, which is nothing but P. Centrifugal force on a horizontal curve will be acting outwards of the curve, but centrifugal force in the vertical curves will be acting either downwards or upwards. If you are moving onto the summit curve, centrifugal force is acting top side, so some part of your weight component is being lifted, is being compensated. So that overall resultant force acting onto you is very less. So that is why when the overall resulting force is acting less, then you feel more comfortable. But when you are coming across the sag curve, which is nothing but a valley curve, your weight of the vehicle is acting downwards, and centrifugal force is also, when you are coming like this, you feel like you are being pulled, or feel like you are being compressed by somebody else. This you can experience while flying bungee jump pandal. When you are being flied high, so you will not feel the effect of centrifugal force, but when you are coming down, you literally feel that so much of weight is being acted on you, and that is how you can experience the way how you travel on the summit curve and valley curve. And the best form of the summit curve is 2-degree parabola. So we have seen what is the best form of circular curve. It is nothing but arc of a circle. You can take any portion of the circular arc, and that is the best form of curve for simple curve. And for transition curve, you can use any of them: spiral curve, Bernoulli lemniscate, where in which the rate of change of radius is keep on differing from point to point, or bringing from infinity to some particular constant value. And the best form of curve for summit curve is generally for visual experience. You will not understand what is the difference between horizontal curve and vertical curve. Only the difference what you can see is in the plan and the elevation, but the form is little bit different. You cannot understand what is the form of the horizontal curve and vertical curve. The form of the summit curve, generally we are going to provide the best form of summit curve is 2-degree parabola, and the best form of sag curve is 3-degree parabola. Here the deviation angle is positive in terms of summit curve, and it is a negative in terms of valley curve. So we'll see what is meant by the deviation angle here. So I'll explain over here. So this is the deviation angle. This is positive. I told you the deviation angle N is nothing but positive. The deviation angle definition is N is equal to algebraic difference of grades. Algebraic difference of grades. So you have to take along with algebraic symbol, okay, and the difference of grades. So the middle should be minus. So there is a algebraic difference grade 1. So this is plus G1, and difference, because the symbol in the middle it is minus, followed by level stretch. So you are having 0. So the ultimate value finally you are going to have G1, that is nothing but a positive value over here. And this is again a positive value. Upward gradient is always represented as positive, but this is a mild gradient. So let me assume for your understanding this is 2%. Sorry, this is 3%, because this is a steeper gradient and this is followed by a mild gradient. If you want to understand the difference between mild and steep, you connect like this and you connect like this, like this. So this is having high high fall when compared to that of horizontal distance. So that is why it has become, so this is +1, so which is steeper gradient. So +3 I am taking for your understanding. This is +2. So the deviation angle n is nothing but +3 minus of +2. So still you are having +1. So the deviation angle again is positive. And here it is, anyhow this is plus, whatever it is, +2 or +3. So plus G1 minus of, this is falling gradient, minus of G2. So therefore you will end up completely plus of G1 plus G2. And this is again, this is a mild gradient. Minus is mild gradient. So minus G1 and this is minus of minus G2, but this is a steeper gradient. So for your understanding again, this let it be 2 and minus of, this is steeper gradient. This is a mild gradient which is having very less value and this is very steeper gradient. So that is why we are going to have higher value. So the falling gradient is higher value. So let it be -3. So therefore -2 plus 3 is +1%. And the fifth case what we have seen is nothing but, so the horizontal road meeting a falling gradient. So this is G1 is equal to 0 and G2 is negative. Let it be -3. So therefore the deviation angle again is algebraic difference of grades. This is 0 minus of minus, that is nothing but -3, which is +3%. So the deviation angle somehow it is not the deviation angle, this is positive. Of course this is positive. This is what represented with algebraic difference of grades. This value should be positive anywhere in the summit curves. Whereas coming to deviation angle in the sag curves, so this is minus G1, the first case minus G1, and this is a level road, so minus of 0. So finally you are ending with a negative value, minus G1. And this is again a mild gradient of ascending gradient, plus G1 and minus, this is a steeper gradient, so minus, I'll take it as -3, and this is +2. +2 -3, so this is, this is +3. So this is because again this is also upward ascending gradient. So +2 +3 minus of +3. So this is -1%. So this is again a negative value. And this is minus G1, which is steeper gradient. So -3, again difference minus. This is -2, a mild gradient, again understanding purpose. So -3 +2, again -1%. And this is minus G1 minus of, this is plus G2. So overall it is minus of G1 plus G2, which is a negative value. And the last value, fifth case, is N1 is 0 or G1 is 0 and G2 is negative, -3. So 0 ascending gradient is positive, sorry. So this 0 plus 3, in the middle it is minus, algebraic difference. So this is 0 minus of +3. So you are having a deviation angle as negative. Deviation angle as negative. So it is not again just like the previous case, the deviation angle, this is negative, but algebraic difference, if you combine both of them by taking the exact symbols, anyhow this deviation will be positive, but if you take along with the symbols, so that is what algebraic difference, this value should be definitely negative value for sag curves, because in the question sometimes you will be asked to calculate the length of the vertical curves and they will not mention you whether it is a summit curve or sag curve. They will not give you the values. So based on the gradient values, whether you are getting a deviation angle as positive or negative, you have to decide whether it is a summit curve or sag curve. Summit curve or sag curve, because you have to calculate what is the deviation angle. If it is coming out to be positive, that is a summit curve. If it is coming out to be a negative, that is sag curve. Summit curve is positive and sag curve is negative. Design criteria. So far we have been looked at what is the difference between summit curve and sag curve. Next, for what all criteria should we design the vertical curve? Okay, the first one is comfort. Just like previously I have discussed it, summit curve is having already a comfort criteria because some part of the centrifugal force is being lifted compensated by the self weight of the vehicle. So overall you will be having reduced amount of weight on you, so because of which you feel comfortable. So therefore you are feeling comfortable, so you need not to design. So this is regarding the design. So if I write the into symbol, we are not going to design for comfort. Whereas a sag curve, we are not feeling comfortable because of the self weight of the vehicle plus apart from the centrifugal force which is acting onto you. So both of them makes you feel uncomfortable or less comfortable. So you have to design for comfort. So we have to decide. We have to design for comfort criteria. Next one, coming to side distance, is very, very important in terms of the summit curve. So this is a summit curve over here. You can see this is the concave downwards, convex upwards. So there is a vehicle over here on the one side of the curve, and there is another object over here on the other side of the vehicle. So if you don't provide reasonable amount of side distance over here, so then you'll not be able to see this object particularly over here. So then you'll end up in undergoing some kind of collision. So that is why you have to decide, you have to design for side distances. One is nothing but you have to decide for stopping side distance. If you look into that stopping side distance, you have a vehicle on one side where the height of the driver is 1.2 meters, and there is an object in front of you at some distance which is a height of 0.15 meters. So you should stop in front of that object such that you will not undergo any collision. So the side distance which is available ahead of you for stopping the vehicle is said to be the stopping side distance. So here you have to, whether it is an object, even if it is one-way traffic, you should have a sight of this much. You should have a distance visible to you in front of you for this particular distance at least. So that you have to design for stopping side distance. So that amount of stopping side distance you need to be available. You need to make available at any point of time, that whatever it is, 180 meters or 2 meters at any point. If you are over here, from here to 180 meters. If you are here, from here to 180 meters. If you are here, from here to 180 meters. Like that, at any point of time, whatever the side distance it is required, you should be able to provide what is the amount of side distance that is required in terms of the summit curve. Next one, the same summit curve, you are also required, for example, there is a traffic which is moving in the opposite direction, then your vehicle also have to undergo overtaking process. So in that case, there is a vehicle which is coming in the opposite direction. So then whatever the amount of overtaking side distance, you know the process of overtaking side distance which we have discussed in the earlier lectures. So where D1 plus D2 plus D3, D1 is nothing but the distance traveled by the vehicle or overtaking vehicle for some point of time during the reaction time of the driver. Followed by the D2, which is nothing but the entire distance traveled by the overtaking vehicle, which is accelerating from behind the slow moving vehicle and coming outside of this lane to the other lane, and overtaking the vehicle of the slow moving vehicle and coming in front of the slow speed moving vehicle, followed by the vehicle which is moving in the opposite direction. So that is what D1 plus D2 plus D3. So that amount of distance you also need to be provided if that is a two-lane two-way road. If it is a two-lane one-way traffic, you have to provide only stopping side distance. If it is two-lane two-way traffic, then you have to provide the distances which is visible to you ahead of you should be equivalent to OSD. You should provide at any point of time, whatever it is OSD, overtaking side distance might be 400 or 5 meters at each and every point. For example, if you are here, from here to, you should have a visibility of 500 meters. If you are here, from here to, again you should have a visibility of 500 meters. So that is how you have to provide the stopping side distance or the overtaking side distance in terms of summit curves. So therefore you have to design for both stopping side distance and overtaking side distance in terms of the summit curves. That is either it is during daytime or nighttime, you have to design for both of them. And coming to drainage criteria, so as the road is at a ascending gradient, so the water will be easily drained off from this. So you are not going to design for this. So I am putting the into over here. The only thing what you have to design is side distance. One is nothing but in terms of stopping side distance. Other one is in terms of overtaking side distance. But whereas in terms of sag curve, we have a comfort criteria. So you have to design for C. Wherever you see the comfort, we are also seeing this in length of the transition curve, where C is nothing but length of regarding to the rate of change of centrifugal acceleration, which is also again the comfort criteria. And side distance, here side distance is not a problem because you are moving here along this lane direction, and there is a vehicle which is moving in the opposite direction. So you are going to see the vehicle which is coming inside towards you easily during daytime. So that is not a problem. Either it is moving in along the same direction like you, or it is coming against the opposite direction for you. Either ways it is not a problem. So there is SSD is not a problem, and OSD is also not a problem. But the only problem is there is another problem during your travel during night time. So that is there is a vehicle going ahead in the along this path So that is your vehicle, and there is a vehicle which is moving in front of you in the night time. But the glare effect of the vehicle will be little bit inclined towards the road. So it is inclined downwards. So because of which your visibility is only present up to some distance. But if that some distance is not equivalent to stopping side distance, then you will going to collide that vehicle. So for which you have to see what is the amount of stopping side distance required for that particular road, and that much amount of distance should be available at least during night time for visibility purpose. So that is said to be, you have to design for side distances, but that is not SSD and OSD, that is said to be HSD, headlight side distance or light beam distance. Generally we prefer it as HSD, which is nothing but headlight side distance. Whether the vehicle is moving in the opposite direction or vehicle is moving before you, either ways you have to provide a side distances which is visible, which is equivalent to that of stopping side distance during daytime. So daytime, how much of stopping side distance is required, that much amount of stopping side distance should be visible during night time for this driver present in the behind vehicle. So the formulas for design of the calculating length of the summit curves is given as, because this is, we were only seeing in terms of we don't have a problem with respect to comfort, and we don't have a problem with respect to drainage in terms of the summit curves. So we have to only decide for design for stopping side distance and overtaking side distance. The first one is length of the summit curve L is equal to ns square by 2 into under root of small h plus capital H. This h is nothing but the height of the object, because the stopping side distance, you will have a object which is present at somewhere. So the minimum height of the object should be 15 centimeters, which is nothing but 0.15 meters, and capital H is nothing but the height of the driver. You substitute the values of small h and capital H, you will end up with the simplified formula where L is equal to length of this summit curve ns square by 4.4, and length of the summit curve. Here there is a problem over here. So there is a summit curve like this, and this is the amount of side distance required. This is S, let this be S. And we don't know whether the length of the summit curve, will be more or side distances will be more. So let this be S, okay, stopping side distance or overtaking side distance, and let this be length of the curve. So whichever is higher, we don't know. So if first condition, you have to assume that length of the summit curve, this L is greater than S, then you have to use this formula. Assume that length of the curve, summit curve what you are going to design, is higher than that of stopping side distance that need to be provided. Then if you calculate that, if your length of the summit curve is going to be higher than that of stopping side distance, then you can keep the value as it is. But if it is not the case, if L is less than S, then you have to use the revised formula. So length of the summit curve is less than SSD, then you have to use this formula, and you will get the exact value of length of the summit curve, which when it is less than SSD. Similarly, you will come to know this easily when we solve one problem on this. Next one, length of the summit curve in terms of OSD is nothing but ns square divided by 2 into under root of capital H plus small capital H, because we are having two vehicles only in terms of overtaking side distance. So there is no object point of view over here. Of course, object also will be taken care, that is taken care in SSD, and these are the two vehicles which are present over here. So you have to substitute capital H and capital H as 1.2 and 1.2. This value is going to reduce as L is equal to ns square divided by 9.6. Again, this is assuming that length of the summit curve is higher than that of overtaking side distance. Here S stands for OSD. Then you have to implement this formula. If that is not the case, you are getting length of the summit curve, whatever you are designed, lesser than that of overtaking side distance, then you have to use other formula, and you get the exact value of length of the vertical length of the summit curve, which is less than that of OSD. Next, length of the sag curve. Length of the valley transition curve is designed based on the two criteria. We have seen that one is nothing but comfort criteria, and next one is again stopping side distance, but this is not called a stopping side distance because this is a problem during night time, so that we call it as better light beam distance or headlight side distance. So this is a formula L, where L is equal to 2 into 2 times of root of NV cube by C. NV cube by C, where V is nothing but length of the speed of the vehicle, N is nothing but the deviation angle, already what we have discussed previously, and C is anything related to comfort is represented as C. And the other criteria is because of headlight side distance, so that is given by formula L is equal to ns square, as S is stopping side distance, whatever you calculate, divided by 2h1. Here h1 is different, that is height of the light of the vehicle. So here you see that height of the light, it is not height of the driver or height of the object, it is somewhere in the middle, height of the headlight. So that is why this value will be taken as h1 is equal to 0.75, and generally the deviation angle for beam will be taken as alpha is equal to 1 degree. So then you have to substitute the alpha value as 1. So then you will get the value of tan alpha. You substitute that over here. So then you will get L is equal to ns square divided by 1.5 plus 0.035 s. Again, this is assuming that L greater than s. Okay, if L less than s, everything is easy, simplify. You take this s square as 2s. You bring here, you completely remove this s square. You put over here 2s minus, you exchange the numerator and denominator. This will be coming to numerator 1.5 plus 0.035 s divided by the rest of our value is n. So that is what, here also the same thing. So here it is, when L greater than s, it is ns square divided by 4.5. But if it is other case, you have to take s square as 2s minus denominator by numerator. So 4.4 divided by n. Here also the same thing. ns square divided by 9.6. So instead of s square, this first term will be common in either of the formulas, 2s minus, and this numerator will become denominator and denominator will become numerator. So this is 9.6 divided by n, as simple as that. So now we will look into the small formulas or small problems which have been given over here in calculating the length of the valley curves or summit curves. A vertical summit curve, here luckily they have given the term as summit curve, but sometimes may not be given. So let us assume that if this term is not given over here, a vertical curve is formed at the intersection of two grades. First, you better draw a diagram to have an understanding what kind of curve is that. So you are having plus gradient. So plus gradient is always represented for upward gradients. So upward gradient, you are having a value of plus 3%, and you are having a falling gradient of minus 5%. So you know the formula for algebraic difference of grades, which is nothing but capital N, which is plus 3 minus of algebraic difference of grades. So it is minus of minus 5, which is plus 8. So 8 is represented as 0.08. So only thing here, the gradient previously, what we have discussed is n, that you have to represent it in 1 in n. So that is horizontal distance. But here, in terms of vertical curves, this capital N stands for percentage. So if it is 8%, you have to take 0.08. So don't get confused over there and here. But the terminology everywhere it has been mentioned as capital N. But again, you have to mention in percentages. Generally, in terms of gradients, we take it as stopping side distance. There, capital N is value and small n is percentage. So the design length of the summit curves. We have to understand to provide a stopping side distance. So the criteria is nothing but you have to provide a stopping side distance. But we are not given the value of the stopping side distance. So for which you need to calculate. So anyhow, I have calculated the deviation angle over here. So now I am rubbing this. So the deviation angle has turned out to be positive. You need not even draw this diagram in this case. If you are familiar with this concept of deviation angle, if you can visualize the things, then you need not to draw this diagram. But it is advantageous while practicing this. If you can go ahead with always a diagram. So the design length of the summit curve. So this is the summit curve criteria, SSD. While deciding the SSD, you have to calculate the length of the summit curve. LS is equal to ns square divided by 4.4. Assuming that L greater than S. Assuming that L greater than S. But where S is nothing but SSD. But you have to calculate what is SSD. We have already discussed to a length how to calculate the stopping side distance. So stopping side distance SSD is given as the formula Vt plus V square divided by 2gf. So where V is nothing but small, speed in meters per second. We have given in kilometers per hour, 80 kmph. You convert that into meters per second multiplied by reaction time of the driver. In terms of the stopping side distance is 2.5 seconds. You substitute the value of that and you substitute the value of meters per second, speed in meters per second divided by 2 into g into the acceleration due to gravity, F. Already we have discussed that if V is greater than 80 kmph, then the value of longitudinal coefficient of friction, here F stands for, this is 0.35. If speed is less than 80 kmph, you have to take the value of 0.4 because the friction is going to be more when the speed is less. So similar like that, you calculate what is the stopping side distance required in this condition. It will be 128 meters. This is a value which you will be getting over here. So now you know that what is the stopping side distance. Now assume that we don't know what is the length of the vertical curve, vertical curve, but it is a summit curve. So then you have to assume that any case, whether it is L greater than S or L less than S. So generally we go ahead with assuming that L greater than S for the first instance. So then L is equal to ns square. N is nothing but 0.08. I told you this, you have to substitute in percentages. Multiplied by S is nothing but 128 whole square divided by 4.4. You get the value of L is equal to 298 meters. Now you have to check that whether length of the summit curve is greater than stopping side distance or not. So 298 is greater than 128 meters. So the condition what we have assumed is correct. So then ultimately the length of the summit curve is 298 meters. So the problem ends over here. Next problem, an ascending gradient 1 in 100. So again an ascending gradient, so meeting a descending gradient. So this also one kind of summit curve. So there is an ascending gradient and this is a descending gradient. Of course this is given as 1 in 100 and this is 1 in 120. So either you can do ahead with calculation of percentages, or better you can go ahead 1 in 100. This is a positive angle and this is minus algebraic difference of grades, and this is a descending gradient, so this will be obviously minus, so therefore minus of minus 120. So this will be something like this. So you better go for the LCM. So 12 5 is 60, so it will be 600. So this is 6 plus 5, that is nothing but 11 by 600. So that is what you are going to get the value of n. N is equal to 11 by 600. Of course you can convert that into percentage also. So this is overtaking side distance. So an ascending gradient of 1 in 100 meets a descending gradient of 1 in 120. A summit curve is to be designed for a speed of 80 kmph. Speed is given as 80 kmph to have a overtaking side distance. So you are asked to calculate the length of the summit curve for a overtaking side criteria, not for a stopping side distance criteria, that which we have done in the previous problem. Now we have to design for overtaking side distance. We know the formula for assuming that L greater than S in terms of OSD condition. We have the formula for the first case is nothing but ns square divided by 8h, which is nothing but 8 into 1.2 meters is the height of the driver. So ns square divided by 9.6. So n is nothing but 11 divided by 600 into s is nothing but stopping overtaking side distance. Here given the value of overtaking side distance. If that is not given, then you have to repeat the entire process of overtaking side distance, where the speed is nothing but the design speed of the vehicle as 80 kmph and the reduced speed of the vehicle or the slow moving vehicle speed is 80 minus 16 kmph. So that is will be 64 kmph. You take V, VB and you take S, small s, 0.7 VB plus L. Then you calculate D1, D2. In the middle you calculate what is overtaking time, total overall overtaking time, capital T is equal to under root of 4s by a. So you have to do each and every process. This entire problem, that calculation of OSD itself will become a big problem. So but you have to be very quick in calculations while doing this. So the value of n is nothing but algebraic difference of grades, which is mentioned in 11 by 600 multiplied by overtaking side distance of 470 whole square divided by 9.6. Then you will get the value of what is the value. So that is nothing but 422 meters. So first condition is assuming that L greater than S. So I've got the value of 422 meters. But is this 422 meters L greater than S? Yes. S is nothing but 470, which is nothing but OSD. But L is not greater than S. I've got 422 and here OSD is given as 470. But I have my assumed condition is I'll assume that L will be whatever I am calculating will be greater than that of what is given value 470 meters. But that is not true. Then we have to revise this formula. We have to go with the second condition where L is less than S. I told you very easily you have to take instead of S square you have to write 2S minus you interchange the denominator and numerator 9.6 divided by N. So you substitute the value of each and everything, you'll be getting 417 meters. This condition is true. Why? Because L less than S. So previously also we got the value as 422 meters. But this and this are very close to each other when compared to a distance of half kilometer. 422 and 417 are very close to each other. But when the L is less than S, you have to adopt only this condition to get the exact value of length of the vertical curve. So that is the problem over here. And the last question is a valley curve. So here also he again mentioned here a valley curve. This is also here summit curve has been mentioned. But sometimes they will not be mentioning your type of the curves over here, but you have to understand from the different grades. So this is a descending gradient 1 in 25 meeting an ascending gradient of 1 in 30. So this is 1 in 25. So falling gradient minus, and this is a rising gradient of 1 in 30. So you have to calculate minus 1 by 25. And this is minus of algebraic difference. Again, this is plus means again this also will become minus 1 by 30. You simplify this in order to get the value of n. So if you express this in percentage, this will be 0.073. So this is the value of n. Of course, this entire value will be negative. So, but this only indication of overall value is negative. That is an indication of valley curve. That's all. So, but deviation angle will be there between the original path or deviated path. So design the length of the valley curve. Regarding the length of the valley curve, we have two conditions. One is nothing but Ls is equal to 2 into under root of NV cube by C. Wherever we are having C, that is indication of comfort criteria. So we know that we have to design for comfort because we are feeling less comfortable in sag curve. So that is why you have to take the value of C. I mean, this condition has to be taken. So there are two conditions. One is nothing but comfort condition, and next one is headlight side distance. So 2 into this n value is 0.073 multiplied by V. You have to convert that 80 kmph into meters per second. You substitute the values accordingly. Divide by, you substitute the value of C is equal to 0.7, 0.6. This value will be 73.1 meter. 73.1 meter. And you have the other case, which is nothing but LS is equal to regarding the headlight side distance, that is nothing but 2 ns square divided by LS is equal to ns square divided by 2h1. 2h is nothing but 0.75. We already have this formula, 2h1 plus 0.035 into S. So you substitute each and everything value, you'll get the value of as 200.8 meters. But before that, again you have to calculate what is the value of S, because the stopping side distance is not given over here. So just like the previous condition, I hope the same speed is given over here, 80 kmph. So the value of S is equal to, there won't be any different value for headlight side distance, that is also equivalent to the same stopping side distance, but this is taken to be daytime and that is taken to be night time. So this, you get the value of S is equal to 128 meters over here. So N is value is 0.073 multiplied by 128 meters whole square divided by 2h1. So h1 is 0.75, so 1.5 plus 0.035 into S. S is nothing but again 128 meters. You calculate that, you will end up with the value of 200.8 meters. So this is 200.8 meters and this is 73.1 meters. Whenever you have more than one or two formulas, then you have to take whichever is higher always, because if you keep this value, then that this criteria will not be fulfilled. If you provide only in terms of comfort, so the lesser value, then the criteria regarding to safety, which is nothing but having a headlight side distance of 128 meters ahead of you, will not be fulfilled. So for which you have to take higher value, then this value will be fulfilled easily when you provide at every point of time in the valley curve. So if you are standing over here and at any point of time you should have a visibility of 200 meters, that is fine. You are having 200 meters means definitely 73.1 is a subset of that. But let me assume that you have provided only 73 meters over here, but in this condition, in terms of headlight side distance, you require 200 meters. But this criteria will not be fulfilled if you provide this. So that is why you have to take the higher value, whichever is higher. So that is the end of the discussion on vertical curves. So I sincerely acknowledge the use of publicly available resources that supported and enhanced the visual clarity of this presentation. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.